Hello everyone, welcome once again to another Python related tutorial by Team Slideshow. In this part, we are analyzing hospital patient treatment data. We are doing recovery score analysis using Python Pandas, Seaborn and Plotly. All these charts are created using Python Pandas, Seaborn and Plotly Express. Here is our analysis report. I will explain you what is the purpose of this EDA, how to load the file. You can see here we have patient treatment data from hospital, and here you can see in this part, which is part 1, we are doing univariate analysis. First we will take all the categorical variables like gender, then patient by department, patient per doctor name, age distribution, treatment cost distribution where we will use a box plot, and recovery score distribution where we will use this plotly chart, interactive chart. Then I will show you how to use this type of box plot, hospital stay days distribution, and if we have to do bivariate analysis, what we can do. But here we will focus on single variables only, and that's why this is part 1. And then I will show you a simple uh, way of putting everything together in a Canva visual so that you can create this type of presentation. So in the next part we will do second part, you will add them. So let's get started with first part. It is very interesting project and it is created for beginners. You will learn a lot of insights from it and a lot of different coding and tricks from it. So let's get started. So now we are connected with Python environment here in Google Colab. So you can see, and this is hospital patient treatment recovery score analysis project. Dataset is here. We have patient ID, department name, treatment type, doctor name, gender, age, treatment cost, hospital stay, and recovery score. So you can consider recovery score as our target variable, and we will try to find effect of other variables or other features on this target variable. What is the main purpose of this analysis? So purpose of this analysis is written here. First, understand demographics, that is age and gender of patient. Identify cost drivers like treatment type, department or doctor, like what drives cost. Evaluate hospital stay duration and their effect on cost or recovery. So in such kind of projects, cost or recovery can be considered as the target variable. Analyze recovery score patterns across departments and treatments, and detect outliers or anomalies in treatment cost and stay durations. So whenever you are starting a project, you can list what is the purpose of your analysis and what are you trying to do here. We will use Python pandas library, Seaborn and Plotly library here to connect the data set and create some visualizations. So here earlier on our channel we did the same analysis using Power BI, and this is what we created using Power BI. This was also EDA, and we are trying to do something similar here also. So when you are working with Python pandas, first task is to import the dataset, which we will import here, and we are import the libraries, importing pandas as PD for data processing, Seaborn as SNS for data plotting and visualization, same with matplotlib.pyplot as PLT, and then plotly.express as PX for interactive charts using Python itself. Next thing, we have to load the dataset. So there are two ways. So you can click here and you can upload that particular file to your session. So here you can see we have the CSV file which we will upload. Once it is uploaded, you can copy the path and your data frame will be pd dot read underscore csv. And once, so you can copy path from here and just paste the path. So this will create our data frame. So this data frame will create or will read the file and present it as a tabular data, a 2D tabular data. And now you can see we have all the columns that were there in the Excel file. Usually we write df.head so that we can see the top 5 rows, and it will give us enough information of what type of data set it is. Whenever you are doing exploratory analysis with Python pandas, remember two more methods, df.info and df.describe. df.info will give you information of whether or not some missing values are there, or what is the data type of these columns. So here, once you will run this, you will see that it has 200 entries and all of them have non-null entries. And data type, when it is a string, for example, when it is alphanumerical, so it will be called as object, age is integer, treatment cost is float, hospital stay and recovery score are also integers. Second is df.describe. This will give a statistical description of data. Like for example, in all the numerical data that we have age, we have treatment cost. These are all numerical values. So in all numerical values, what is the mean? So average age is 41.71. Average treatment cost is 79,698. On an average, a patient stays around 16.01 days, and their average recovery score is 70.37 or 70%. So this will give you idea whether some missing values are there and how the data is distributed. You can also see 25 percentile, 50 percentile, 75 percentile, and the maximum value of age. So minimum age of patient is 1 year and maximum is 19. So between 1 and 50, the 25 percentile value is 19. Then 50 percentile is 40. You can see it is close to mean, 41.71, and third quartile is 62.25. So you can see how the data is distributed. So this is something that you can do, and this will help you in understanding about these variables. What is highest recovery score? What is lowest recovery score? While doing EDA, always check for missing values. So you can see here, if your data has some missing values, so you will write df.isNull.sum, and if your data has some duplicated values, so we'll write df.duplicated.sum. So once you will do that and run, so you can see we don't have any missing values. So first we will run this, so you can run them separately, and then we will run this. So here you can see we don't have any missing values. So this is something that we usually do while exploring the data. So next thing that we will do is univariate analysis. In univariate analysis, the first part is categorical variables. Whatever categorical variables we have, like department, treatment, doctor name. So if you remember our Power BI, this video is also there, or whatever fields that we usually use, like department. So average recovery score by department, average recovery score by gender. These are categorical values. So once we have that, so here we are using Seaborn libraries count plot, and in count plot you can see we are writing X as gender because this is the first categorical variable, and then data we are saying is df. So count plot takes two arguments. One is what is your x axis and what is your data. Others are also there, but these are important. And then we can write plt.title, and then we can write plt.show. So this is we imported matplotlib.pyplot as plt. So plt.title will set title to our graph, and plt.show will actually show the data. So once you will do that, you will see gender distribution, and this is the easiest way to see categorical plot. So here you can see that most of the values are male. Most of the patients are male, that you can see here as well. Here actually we saw average recovery score, but here we are actually counting these values. How many male, female and other values are there. Similarly, here what we are doing in y-axis, so here in x-axis we kept gender, here in y-axis we are keeping department, then we are using data is equal to df. Another argument that we can add is order. So order equal to by what value do you want to order the chart. Here you can see order is in alphabetical order. Here you can see we are ordering by df.department.value count.index. So before that we have to understand what this does. So many of you will already know this, but this particular method dot value counts, this gives us information of how many values of each department do we have in the data set. Like in total we have 200 rows, but department wise how many values are there. You can see some departments are gastrology, some are pediatrics, etc. So when you will run this, you will see that gastro is 41, pediatrics 38, orthopedics 31, 38, oncology 31, and least are the lowest value is in cardiology, lowest value of patient, count of patient. So now here you can see gastrology has the first order. So that's what we are doing, not index. So we are ordering by index in their value count. Now once you will run this, you will be able to see. Now because we use y chart, y axis, so now this is giving us horizontal chart. When we used x axis, it gave us vertical chart. So like here you can see this is horizontal chart, this is vertical chart. So similar thing we can do here also. So this is patients per department, and we can see highest number of patients, the highest count of patient is in gastrology. You can do the similar thing for doctor name also. Let's say we want to do it by doctor name also. So we can include a code here, and here just replace department with doctor name. Remember in our column name we have a space. So we have to use that space, and order by also we will use doctor name, and we will say patients per doctor name, like doctor name wise data. And here once you will do that, you will be able to see that Mr. or Dr. L. Khan has the highest number of patients, then R. Singh, then M. Patel, then T. Mehta and A. Sharma. Here you can see like we are using Seaborn SNS. So in SNS we can also set palette. So in palette you can use set 1, set 2. I will give you other options also. So here you can see in set 2 we have this color. Another one is cool warm. So you can use that. So I will give you this list that you can use in your visuals. So you saw how to create charts for your categorical values. That is univariate analysis, analyzing a single variable. Now we are doing numerical variables. So single numerical variables, important variables are age, treatment cost, hospital stay and recovery score. So for categorical values, we univariate analysis of categorical values we used count plot, and for univariate analysis of numerical values we have to use histogram plot. So we are using sns.histplot. In histplot it will take one value which is age. So here once you will run this part, you will be able to see how age is distributed in the data set. So basically when we have done KDE is equal to true, that is kernel density estimation. This will enable this type of curve over our charts, which helps us in finding out probability, like what is the probability of finding values in that particular area. It automatically creates bins. So you can see 0 to 10, 10 to 20, 20 to 30, and so on. So these bins are automatically created, and on the basis of these bins, it is creating, or it is showing us that between 0 to 10, how many values are there. So between 0 to 10, around 40 values are there, we can say, or 35 are there. And just for your reference, I can show you. I have opened Canva. In Canva, I am using thumbnail size like 16 is to 9 ratio file. So you can see I can use some charts over here. So for example, here when we have charts, so this is patient for doctor name. So I can copy image and I will paste here, and I will just resize it, because in first row I will add all the univariate analysis I did for categorical values. So patient per department, we can copy image, we can copy image, and this is Canva. We will simply paste it. This is not necessary, although your, you know, that chart is enough, your Python pandas report is enough, but you can actually use this kind of analysis. You can arrange these charts to show something as a dashboard, as we usually do in case of Power BI. This is something we can do. Similarly for this, we can do that. I'm just showing you. I could have done that separately, but I'm just showing you how you can also represent your reports, and later I will let you know how to publish this. And we can actually publish them as PPT files, we can publish them as uh, PDF files. That will help everyone in understanding how data is distributed, how data is presented, and where we are actually answering different questions. So you can arrange their height. So this is how you can add all your analysis visuals that we will do. And here you can add some kind of heading. So we are doing exploratory analysis, so we can copy from here. So hospital patient recovery score analysis project, and we can add as a heading, and you can see in the second line, because for you guys I have to mention what type of technology is being used. So I will use this, and I will just enter here. For this I will just make it italic, and from here you can actually use some other fonts. So it's your choice. This is not good for me, so this is okay. So you can use some other fonts. Here also you can use some other color, something. So it will automatically give you some colors that are already there in your report. We can also reduce size of subheadings. So this is what we can do, and for this I will use the secondary font here, this one. Okay, and then we will populate the second row similarly. Now we have done some analysis. So this is how we have first numerical value distribution, like age. We can see most of the patients are between 0 to 10 age, kids are there, and between 80 to 90 we have around 15 people, and majority of them are there like 25, 22 are there in between, in age of 20 to 40 also. In the exact similar way, what we can do, we can add one more code cell here, and we will use box plot. So here we use histogram plot. I am just showing you use of different type of charts also. We can also use box plot, where we can use y-axis. So in box plot you write y and data, same as we did in case of count plot. So what this box plot does, obviously it will give you box and whisker plot. So you can see, and here you can see how it is distributed. So treatment cost distribution, we have a minimum value, we have a maximum value, and you can see this box represent the range here. So on my website I have uploaded this information. What is a box plot? So usually like here the box plot is a vertical one. It can be a horizontal one as well, where we have a minimum value and a maximum value. So for example, what is the minimum value of treatment and what is the maximum value of treatment? When you saw the statistical distribution, here you can see, so you saw these values: 25%, 50%, 75%, minimum, maximum, mean. So minimum value 5444. So that you will see here. Minimum value around here somewhere. Maximum value around here somewhere. Then where the box starts. So this is called lower quartile and this is called whisker range. So like or whisker value. So this is whisker, and this also tells us how data is distributed. Lower quartile, upper quartile and median are there. In real case, you will see that median is very much close to the mean value and or 50 percentile range. So in our case also you can see it is close to 80,000, and you can see here that information. Mean is also around 80,000 and 50% is also around 80,000. So this is showing, this line is showing that this is upper quartile, this is lower quartile, and this is interquartile range. So we can see that most of the values are falling between these range, the range of this box that you can see, but we have some higher and lower values also. This is what it shows, treatment cost distribution. Similarly, we have another histogram where we are using recovery score. Now in this histogram you can see we have 336 and 39 bins. Here we are saying number of bins should be 20, and show how recovery score is distributed. How many patients have recovery score between 40 to 50, 50 to 60, and so on. So once you will run this one, you will be able to see that recovery score. So now we are analyzing all the single variables, okay, and this is, we are here, we are not using PLT here like SNS. Here we are using Plotly. So in Plotly you can see we imported Plotly as px. So plotly.express as px. This is a chart. What is difference? Like if here, if I am taking my mouse over, so it is not showing me any data or information, but here actually it will show some value that this is recovery score. What is this showing? That between 40 and 50 recovery score. So this will be around 40 to 44, you can see. So between recovery score of 40 to 44. So here one bin represents recovery score of 4. So between 40 to 44 there are 20 people. 20 people have very low recovery score. Peak is at here. Recovery score 80 to 84 is of 21 people. And here you can see a very high recovery score is also there, but this is of very few people, only 3 people. So these type of charts are there. So we can copy this one also. Let's copy this image. As I said, this is totally optional, but you can add. So you can add it here. So this will help you in data visualization. And similarly, we can add recovery score also. So here you can see with the help of guidelines, width is also equal. And for recovery score, because it is Plotly, so you can see that option will not be here. So one thing that we can do, we can take a screenshot, and or we can download this, and we can actually paste this screenshot here. So it will be added here, and I will just reduce its size and use 2 times the width of these charts. This will be good. And recovery score. So this is univariate analysis so far. Next part will be the bivariate analysis. Bivariate means you will take one variable from one part, like one numerical variable and one categorical. For example, average recovery score by gender. So here we are using average of recovery score and analyzing by gender. This is bivariate. If we see single variable distribution, like here or in a distribution chart, that is univariate analysis. But before we do bivariate analysis, if we have to create a box plot with Plotly Express, so its function is or method is px.box, like px.histogram, px.box. Here it is box plot, and here you will write df. So first parameter will be df, second will be x axis. So on x axis, what your parameter will be x, what will be treatment type. On y we are writing treatment cost. So this is also one kind of bivariate. Here we are, where you are actually using box plot. So here you can see what happens. So this is treatment cost by treatment type. Okay, how this is distributed. So this becomes bivariate. But since in the first part we are doing univariate, we'll add one line of code, and here we will just remove y-axis. Okay, x-axis, and this will become single, and here you will be seeing this. So now it is showing treatment cost by treatment type. So you can see minimum value, maximum value. So here also we created something similar, treatment cost distribution. So if you want, you can show it like this as well. I am just giving another example here. So this is something that you can do in in Python pandas, and you can analyze the data. So since we have not analyzed hospital stay days, like what is hospital stay days information. So instead of treatment cost, we will just write hospital stay days. So let me correct the spelling. It is actually written like this. So it is case sensitive, and you actually have to write it exactly in the same way. So now once you will run this, and we have to change the title also, hospital stay days distribution. And if we actually have to show it as a vertical chart, we will use x-axis. So here you will be able to see the box plot as a horizontal data, and if you have to see vertical, you will use y. These type of charts are very important. So if you will use single, it will show like this. If you will use both, it will show like this. So this is another chart that we can use for our report. So practice part 1. For now I'm just using this chart. So I will just copy image because I just want to fit it properly. Hospital days distribution, and our univariate analysis is now finished. In the second part, we will study about bivariate analysis, and that will give us more information how the data is distributed, how the variables are affecting different type of target fields that we have. Till then, practice this much. If you have any questions, please let us know. We will be happy to answer, and I will share the link of this code also, so that you can copy the code and work from your end as well. And I will give you the link of dataset also, so that you can load it and analyze data. If if you have any other type of requirement related to this project or something similar, please let us know in the comment section as well. Thanks once again. Please hit like for this video, so that, and subscribe to our channel. When we will upload the second part, you will get the notification. Have a nice day.